Okay, sets day 1, part 2. We're now going to draw pictures of our sets. So we have a universe, that's this whole box, every number in the box. And then we have some set A, in this case this will be my set A, and in A we have 2, 7, and 8. And then we also have A complement. Well, that's everything not an A, so A complement must be out here with the numbers 3 and 5. That's the general idea, and we have different versions of that. So the first one is a subset, and I want the subset of B being a subset of A. So the whole box is my universe. A would be on the outside, so it's that circle. Everything in this circle is A. And then B is the inside circle, everything in this circle. So this middle part is the subset A inside of B. And there's a math notation. We say as B is a subset of A, then B is contained within A. So it's all the way within A, as every element in B is also in A. So maybe, for example, A is 1, 2, 3, 4, and B is 2 and 3. It's containing all of those numbers. We have intersection. Okay, so we have some universe, an A and a B, and the intersection part is this middle part. This is A intersect B. That's where they overlap. We'll do it with numbers in a minute. Okay, union. Well, again, we have our universe, which is the box, some set A, some set B, and the union is everything in here, and everything in here. So it's everything in A, B, or both A and B. We also have disjoint. And disjoint just means that they have nothing in common. So here's a picture. This is our universe. Maybe this is A and this is B. And in this case, maybe A has 2, 3, and 8. And B has 4, 5, and 9. Notice that none of the numbers are the same. Where if I went up to intersection, maybe A was 1, 2, and 3. And B was 2, 3, and 4. A would have 1, 2, and 3, and B would have 2, 3, and 4. They would overlap. So, and notice that A intersect B is the empty set because they don't overlap. We also have something called disjoint and exhaustive. They don't overlap, but they also fill up the universe. So maybe we have some set A that's half of it, and some set B that's the other half. In this case, they don't intersect, but also their union is the whole universe. Okay, versus the union up here, we could have had numbers out here, or number of elements out here as well in the universe. And lastly, this is also disjoint and exhaustive, but we could have 3 separate ones. So we could have A, some set A, some set B, maybe it's bigger than A, has more numbers in it, and some set C. And again, they never intersect, but if you put them all together, you get the whole universe. All right, let's look at this with some examples. So same ideas, but with shading. If I just told you to shade set A from this first picture, well, set A is everything in this circle. So that would be set A. If I told you to shade A and B, just like we did before, it's the part that overlaps, so that's A and B. B complement, well, that's everything that's not in B. So here's B. All right, we want everything that's not in B. We're going to actually have to make that a little bigger. That's everything that's not in B. And I should not even be overlapping. That's really sloppy. I shouldn't be overlapping at all. There should be nothing. This should be all the outside stuff. you get the idea. Okay. If we did a picture of A intersect B complement, here's where it gets kind of interesting. So A is this. Whoops, let me make it smaller. A is this whole circle. B is the other circle, and B complement is everything that's not in B. So it's all of this out here. So A intersect B complement would be where they overlap. It would just be this little moon shape. That is A intersect B complement. So if you were asked to draw it, you could draw it and just shade in this part. Or if you did it, you could say that A intersect B complement was maybe where it overlapped. So maybe it would be just this part if you need to do both. All right, and here's kind of a cheat box where it tells you what A intersect B is, as well as if you had 3 sets. You could have 4, 5, 6, but we don't deal with anything more than 3. All right. Lastly, we have putting numbers in the regions. So it's all the same thing over and over again. Let's put some numbers in the region. So for the first one, we have region P. How many elements are there in P? Well, we're just asking some questions. In P, there are 7 plus 3, or 10. Okay. How about Q? Well, in Q, Q complement. So Q complement is everything that's not in Q, so it would be this one and this one. So N of Q complement is 7 plus 4, or 11. Okay, how many in P union Q? Well, that would be in everything in both of them. So 7 plus 3 is 10, plus 11 more. So the number in P union Q is 10 plus 11, or 21. P but not in Q, so it's just this one. So that would be 7. I'm going to leave out the notation at this point. Well, I guess if you wanted, let me show you the notation. That would be the number but P, but not Q. Okay, Q but not in P. You could see that that's 11. And in neither P or Q, that would be, hopefully it's obvious, that would be 4. And then if I ask what's the number in the universe, well, that's everything in the box. That's 10. 21 plus 4 is, we have 25 numbers we're talking about. And we don't know what the numbers are. This is just how many are in there. Maybe this is the number 2, 4, 5, 3, 2, 4, 5, 1, 2, and 6. That's 1, 2, 3, 4, 5, 6, 7 numbers. That's what it's saying, is there are 7 things inside of there. Okay, we just don't know what they are. But now it's asking us to add and subtract. So it says, given that we have some universe that has 30 things in it, the number in A is 14. So everything in A, there are 14 of them. Okay. In B, there are 17 things. And in A intersect B complement, there are 6. So I know there are 6 items in here. Okay, and it says how many are in A union B? Well, if there are 6 items in just this piece, and the whole circle has 14, 14 take away the 6, that means there's 8 in this piece because there are 6 in here. And then for B, B has 17. So 17 take away the 6 that it shares with A, and we have 11. So how many are in A union B? Well, 8 plus 6 is 14, plus 11 is 25. How many are in A but not B? Well, that would just be 8. So you need to be able to do that. And then it says show, this would say something like show that A union B is the same as all of A plus all of B minus the intersection. What do I mean by that? Well, we know now that we have 14 in A, 17 in B, and that's how it breaks out. So A union B, we just said was 25. Well, in A there are 14, in B there are 17. 14 plus 17 is 31. Okay, so we have 31. Subtract the intersection, subtract 6, and we get 25. So that's just a rule you need to know. And now let's go back and answer the question from the first page. This is what they have you use this for. Okay, it says, a city has 3 newspapers, A, B, and C. This is on your first page of the notes. Of which the adult population, 1% reads none of these newspapers. Okay, so that would be, and this is how I always do this. So the probability of none is 1%. Okay, 36% read A. Probability of A is 36. 40% read B. Probability of B is 40. 52 read C. Probability of C is 52. 8% read A and B. So A intersect B is 8. 11% read B and C. And 13% read A and C. And finally, the probability of reading all 3, A intersect B intersect C, is 3. And it asks some questions. What percentage read newspaper A, what percentage read newspaper A only? So that's the probability of just A. And so these are the questions transposed. The next part it says newspaper A or B, that's A or C, that's A or C. And then lastly, A or B, but not C, that look like that. So we're going to use what we have and fill in my picture so we can answer the questions. So I always start from the inside out. The probability of of being in A, B, and C is 3. So that's 3. Now we're going to start with the little pieces. So probability, and let's name these A, B, and C. We have 3 in the middle. The probability is 3%. The probability of just being in C, where there are 50, no, sorry, we don't want to do that. There are 13 in A and C, which would be this piece. But there are already 3 that are in both. So 13, take away the 3, there would be 10 in here. Okay. There are 11 in B and C. 11, take away 3, would be 8. And there are 8 in A and B. 8 take away 3 is 5. Now we look at the big pieces. Probability of being in C. There are 52 in all of C. So we have to think 52, take away the 10, the 3, and the 8 that we've already used, and there are 31 in C. Similarly, we would have 24 in B and 18 in A. And we're running out of time, so I will have you now answer these questions, A, B, and C,